Welcome back to the fifth episode of the Decomposition Pattern Podcast, where we break down the hottest takes in tech and programming into their fundamental components. We separate signal from noise, tackle complex topics with clarity, and rebuild our understanding from the ground up. This is José, and today we're going to talk a little bit about abstract class in object-oriented programming languages. This topic was actually triggered by a question from a friend of mine, Nelson. I don't know if you're listening, but thank you so much for the topic. And he clearly questioned me, hey, should we avoid using abstract classes in object-oriented programming languages? And I thought that this might be a really interesting topic to talk this podcast. So there are kind of two major points I wanna pass on, right? First, let's just try to understand what are abstract classes, why do exist, what their usage. But we'll also let's then answer the question properly, right? Should we avoid them? If not, then why would Nelson think that it would need to avoid them? So let's talk a little bit about this. So first of all, what are abstract classes? So we reach for abstract classes, as the name implies, for defining concrete behavior of something. That's why it's called an abstract class, right? So it has this concrete behavior that then is shared via inheritance to subtypes of this class. So a very small example, right? So we all breathe, right? All humans, animals, we all breathe. But let's just go into the subset of humans. So if I have a class human that breathes, so I can define in an abstract class called human, for example, the implementation of breathing, okay? And then I can just have a concrete class called Nelson or José that extend that abstract class of like human, and we both inherit that behavior of breathing. There's no need to redefine it twice in this example, right? One for me, one for Nelson. But yeah, so it's a way of sharing this concrete behavior. And they are not limited to just sharing concrete behavior. We can actually use abstract classes as a kind of a contract, or I wouldn't say interface because they are not an interface. Interfaces in some programming language don't define concrete behavior. In Java, it will, obviously. But that's not the point of an interface. But yeah, so we, like I was saying, they can be a kind of contract or a type of interface, but where we can also have defined abstract methods. So they are methods that need to be implemented by the subtypes, but don't have a behavior defined on the base abstract class, let's say. So there's a lot of things that they allow us to do. So that's the point of an abstract, is define this kind of contract that may or may not have predefined behavior already programmed, right? And then all subtypes are obligated to implement any abstract methods or then completely inherit the common behavior, and they can also override already defined base behavior, right? So you can see there's a lot of things that we can do with abstract classes, and we can probably already understand the question from Nelson, right? So should we avoid them? I wouldn't necessarily say we should avoid them, like making this big effort to not use them, but I would say to be very careful in its usage, like everything, right? Especially associated with inheritance. We need to be very careful about the possible intrinsic keys and the inheritance graph that might happen, because I might extend a class, right, or extend a class that extends an abstract class, and then can go really complicated way of implementing a thing in its whole. And even it's kind of complicated to understand the blast radius of changing something, right? Because of all of these inheritance, let's just focus on an abstract class and only a subclass. that extends that abstract class, like inherits their defined behavior. If you change that abstract class, you're going to change all subtypes immediately. But that's a common problem with simple inheritance, right? You extend something, and if that something changes in its behavior, it's already kind of reflected in all of its subtypes, unless those subtypes are already overloading that behavior or completely replacing it, right? So it kind of gets really, really weird if you're not careful with abstract class. But then, even if we don't go into these kind of technical details, if depending on the project organization that somebody might take, for example, let's say that they are not following MVC and they are actually doing as a domain-driven design type of organizing the project, right? So that might be a problem referencing an abstract class from another domain, right? That breaks the domain context, that breaks the own encapsulation. So anything that happens in that other domain will impact my domain where I'm using that abstract class, right? Or referencing that abstract class. So we can see that there are a lot of things that might happen that we might not be aware of that directly influence the responsibility of the final class, right? Because I guess that's the point. When we're defining something abstract, is not the concrete or the final implementation. So it's something, it's not corresponds to the final thing. It's like a general, an idea. But then when you go into the concrete thing that inherits that behavior, if that base behavior change, then everything might kind of break, right? Thankfully, there's tests that can catch for such things, but I would say it gets really, really weird, and in my experience, it gets really unmanageable to use abstract classes. So if you want to define a common set of behavior, I would say don't worry or don't focus too much on the behavior itself. Maybe we can define interfaces that, with the sole purpose of saying whatever implements this interface should define or should implement also this behavior. And if you want to share concrete implementations of that specific behavior, maybe you can use traits, because traits generally don't need to, obviously aren't used by inheritance, but they kind of pushes us to use more composition, right? So it's like a Lego block that you can use to build a car, a house, whatever comes into your mind, and you're not totally bound by the outside context. You're only bound by its inner behavior. It has some of the same concerns. If you change behavior, you can change everywhere where the trait is being used, same thing, right? But since its unit is generally smaller, then I would say that it's generally more interesting to maintain or more easy to maintain, okay? So Nelson, to answer your question, it's not necessarily that we should avoid them. We should be very careful about how we use them and in the context that we use abstract classes, okay? So be very careful to know if your team is referencing abstract classes in different domains, if you're using like that, and even if you don't use domain-driven design, if you're using other project architecture, it's the same concern overall. So I would say to be very careful, to always try to do some code co-location, to have that abstract class closer to all of its subtypes, so that when you change something in the abstract class, at least visually, by looking into the file explorer or something like that, you know exactly what would be the predictable blast radius, right? What will change. Obviously, please be very careful and have test coverage, so you know when things changes in an unexpected way that introduce bugs. But other than that, I would say to avoid, I would just say again, reiterate, to be very careful in the context where it's being used. And basically that's it that I have to say about this. So once again, I'm gonna call to join our Discord server. You can quickly access an invite by going into discord.thedecompositionpattern.com. You'll be invited to our server, and we have this kind of interchanges. So join us and come share your views, Should we avoid using abstract classes in object-oriented programming languages? Are you using them? How are you using them? Is there any concern? So come join us and let's take this discussion into Discord server. Right? That's it. See you on the next episode.